Hello everyone, welcome to today's video. So in the last lecture, we have discussed about the quantity regarding the quantity estimation of the sewage from the sewerage drain of the sewage as well as the stormwater drains. So today we'll discuss about the quality and other aspects of sewage or domestic wastewater as we would like to call it. So in the quality, there are several aspects like physical characteristics, chemical characteristics, and biological characteristics. So, as a matter of fact, we have learned physical characteristics in the same way for water supply also. For when we had studied about in the previous unit, when you studied about water supply and water treatment, we had also studied about the physical characteristics and chemical characteristics of water. But this is different. So here we are going to same study we are going to do on sewage. So again, the physical characteristics it will be same: turbidity, color, odor, and temperature. So sewage is normally turbid, resembling your dirty dishwater or wastewater from the baths, having other floating materials like facial matter, pieces of paper, cigarette ends, mastics, greases, vegetable debris, fruit skins, soaps, etc. So again, like in water treatment and other measuring the water quality for turbidity, for sewage also the degree of turbidity can be measured using turbidity rods and turbidimeter. This has already been explained in the previous unit. Color. Next is the color. The color of sewage can normally be detected by the naked eye and directly see it, and it indicates the freshness of the sewage. Now, if the color is yellowish, gray, or light brown, either of these three colors, then it indicates that it's a fresh sewage. However, if the color is black or dark brown, okay, darker version, then it indicates that the sewage is already stale. It has elapsed 3 to 4 hours has elapsed. It's not fresh anymore. And during those 3 to 4 hours, the oxidation, biological oxygen, dissolved oxygen has been replenished or has been consumed, thereby leading to the deterioration of DO. Okay. Again, in the same manner, like in water treatment also, we measure the order using ton threshold order number. That is the measurement of order. And if it becomes stale, then it's a very pungent smell, like what sewage will smell, normal sewage will smell. Next is the temperature. Temperature, it has an effect on the biological activity of bacteria in the sewage. See, here temperature is very important in case of sewage. It might not be of that importance in case of water supply. It might be the room temperature, but here it plays a very significant role. Why? Because for the sewage, whether it is aerobic decomposition or anaerobic decomposition, whether in presence of oxygen or in absence of oxygen, the decomposition of the sewage, okay, from fresh sewage to stale sewage, it will be governed by temperature. Temperature is one of the most important controlling factors. So if the temperature is little bit high, your biological activities will be more. BOD will be more. Okay, BOD will start deplenished, just start decaying. Decay of the organic matter present in the sewage will start as soon as the temperature rises, and it will lead to fall of dissolved oxygen. BOD will rise, but dissolved oxygen will be falling. Okay. Now chemical characteristics again, it contains total solids, suspended solids, and settlable solids. Now suspended solids are those solids which are in suspension. Settlable solids which are after suspension. Some of the solids will settle down the beaker. So those are settlable solids, and this the combined these are total solids. So you have to measure this total solids, suspended solids, and settlable solids. As same in the case of water supply, what you used to do, same here also we have to suspended solids are those solids which remain floating in the sewage. Dissolved solids are those which remain floating in the which settles once the sewage is allowed to uh, remain stationary or remain undisturbed for 2 hours. Okay. So again, if you filter the solid, you can find the what is the amount of total solids present. Once you evaporate, you can find the dissolved solids. So like the same way, what you wish to do in the water treatment, how we used to find all these quantities in case of water treatment plant or water supply. Same way for sewage we have to do it. Okay, the next is pH. So pH is again like temperature. pH is another very important chemical characteristic. So pH is nothing but the negative logarithm of hydrogen ion concentration. Okay. If the pH is less than 7, then the sewage is acidic, and if it is more than 7, it is alkaline. So generally, what happens is when the fresh sewage is alkaline, when the sewage is fresh, when it just comes out from the water closets and the toilets and the wash basins and all, it is just collected in the sewer, freshly collected. That is always alkaline. But as and when time elapses, due to bacterial decomposition and decomposition of all the organic matters, replenishment of the not replenishment, in fact, degradation of the dissolved oxygen and BOD content, increasing of the BOD content, the pH of the sewage will start transitioning from the alkaline to the acidic stage, and it will come less than 7. It maybe fall to 5. It might fall to 6 or 5.5. So as and when it becomes more and more stale, it becomes acidic. Okay. Again, chloride content, nitrogen content. Okay, then presence of fats, oils, and grease. Why this is important? This was not in the case of water supply, but here you have to add, because this will come from the fats, oil, and grease will come from the kitchen when you wash the utensils. Okay, the utensils uh, that are being, or the dishes that are being washed, they'll contain a heavy amount of oils, fats, greases, and all these things. So this will also contribute. In fact, these are sticky material. This might uh, choke the sewers also. So this presence you have to find out what is the amount of fats, oils, and presence. This is there. Sulfides, sulfates, and hydrogen sulfide gas. These are also important components. And last but not the least, these are the biological things. That is, what is the dissolved oxygen, what is the biological oxygen demand, and what is the chemical oxygen demand. This you need to find out in case of sewage. So dissolved oxygen, the determination of dissolved oxygen in sewage is very important, because while discharging the treated sewage into the river stream, it is necessary to ensure at least 4 ppm of DO. 4 ppm is 4 milligram per liter of dissolved oxygen must be present, okay, in the stream, or in not in the stream, sorry, in the sewage. So you cannot keep the dissolved oxygen content to 0. In that case, all the aquatic life, if you're disposing such sewage in the river or any aquatic body, water body, the aquatic life will be hampered, because for fishes to live there or any aquatic animal to live there, the least amount of DO, that is dissolved oxygen, that is required is 4 ppm. So that much amount you have to ensure before disposing it to the water body. Now the DO test is performed on sewage before the treatment and helps in indicating the condition of the sewage. If the temperature of the sewage is more, the dissolved content will be less. The solubility of oxygen in sewage is 95% of that in distilled water. So again, the DO content is determined by Winkler's method. It's in you have learned about titration and all that, oxidation reduction processes in your chemistry. Okay, so the titration method is followed, in which potassium permanganate or any other titrating agent is used along with sulfuric acid, and that sewage is titrated, and then the amount of liberating oxygen, that is oxygen is liberated, that is the dissolved oxygen, okay, that is found out. So that needs to be found out. That is, biological oxygen demand is the amount of oxygen that is required for the microorganisms, okay, and for to live, for the further decay of the sewage. That is biological oxygen demand. Chemical oxygen demand is the organic matter present in the wastewater. It can be measured in a number of ways, like volatile solids determination, being a crude measure of organic matter. Now, if organic compounds and their concentration are known, the theoretical oxygen demand of the wastewater can be accurately calculated. But it is virtually impossible to know the details of organic compounds present in any natural raw water or wastewater. The chemical oxygen demand is therefore determined by performing a laboratory test on the water with strong oxidant like dichromate solution, and theoretical computations of chemical oxygen demand are performed on water solutions. So for biological oxygen demand, the organic matter is of two types. That is the biologically oxidized, and it's called biologically degradable and biologically non-degradable or biologically inactive. Okay, so but we are mainly interested in finding out the amount of biologically active organic matter present in the sewage. So testing is carried out to determine the biological oxygen demand of sewage, which directly gives us the amount of biologically active organic matter present in the sewage. See, every sewage will contain certain organisms at a particular temperature. The dependence of the controlling factor, the governing factor of temperature is also very important. At a certain temperature, the amount of organisms present in the sewage also lead with the amount of organisms will lead to the decay. More the organisms, more will be the decay. More will be the more with the temperature, the faster will be the decay. And for these organisms to survive, they need oxygen. So what is the oxygen demand for such active organisms, biologically active organisms present in the sewage? That is nothing but your BOD. So it is very important constituent. In sewage treatment, BOD is one of the greatest and one of the most important and significant parameters that needs to be understood here. Okay. In fact, DO and BOD, COD is just a term that is not of much significance, but the DO, dissolved oxygen. Dissolved oxygen is mainly related to your dilution, disposal. Okay, for the disposal of the sewage in your rivers. There, this parameter is important, but BOD is important in any measurement of sewage. BOD is the most important parameter. Okay. Now, there is a formula to find what is with the BOD. BOD is dissolved oxygen consumed in test by diluted sample into V2 by V1. Now, what we do is we take, say V1 is the volume of undiluted sewage sample, and V2 is the volume of diluted sewage sample. When you take a certain volume, V1 says you take 100 ml of undiluted sewage sample. You took 100 ml of sewage sample, and in that you added 200 millimeter of water. Okay, and you diluted the solution, so the volume becomes 100 plus 200, 300. Okay, so now V2 by V1 will be 300 by 100, that is 3. So this ratio V2 by V1 is also called as dilution factor. And what is the DO consumed in these dilutions? When you dilute that solution of sewage sample, when you dilute it, obviously the DO will change. The initial DO and the DO deficit will give the net DO, dissolved oxygen, consumed in this process of dilution. That you can find out using the titration process. If you know that DO, if you know these volumes, you can find what is the 5-day BOD. Okay. Another formula for this is YT is the amount of BOD present at time T. T referring to T days. Okay. The total BOD remaining after T. So this is given by the formula L into 1 minus 10 to the power minus KD into T, where L is the initial BOD before start of the dilution, before start of the reaction. KD is deoxygenation constant or BOD rate constant. Another formula for finding KD is KD at T degree centigrade is KD at 20 degrees centigrade into 1.047 to the power T minus 20 degrees centigrade. So what happens is you KD at 20 degrees centigrade, this is something that will be given in the question that you know already. 20 degrees centigrade is the standard temperature. For that they have found. Now if you need to find for the temperature of say 35 degrees centigrade, then this will be KD at 20, whatever the value, that into 1.047 to the power T is 35 minus to the power 15. So that will give the value of KD. That KD you have to put here and the number of days T. So if you need to find 5-day BOD remaining after 5 days, then put T is 5 and find the initial BOD, ultimate first stage BOD. It will be given. So you can find what is the remaining BOD after 5 days. See, initially when your reaction starts for the organisms, or the decay, before the decay starts, there will be a particular BOD. After 3 days, that BOD will start falling down. Decay will start. Okay. So what is the amount of BOD that is remaining? So this equation is given. This is an exponential equation. Okay. So this is the first stage BOD. Derivation of the equation of first stage BOD. Okay. So what happens is, see, this is LT, that is the BOD remaining at T days, and this is a time t. So this graph, this is an exponential decay. This graph is called an exponential decay graph, which is used by the formula that is given. Now the assumption is the rate of change of BOD remaining with time t, dLT by dt, is directly proportional to the amount of the BOD remaining at time t. That is, dl by dt is proportional to LT, where LT is the oxygen equivalent of carbonaceous or oxidizable organic matter present in the sewage after T days. There is a BOD remaining after T days. In short, in other words, you can say LT is the BOD remaining after T days. So K is one constant. For removing the proportionality constant, you need to proportionality sign. You have to introduce one constant K. So dl by dt is, why it is minus, because it is decaying. The BOD is falling down, okay, with time. So this unit, from this derivation, they have found that derivation, that formula. Okay, this is the first stage BOD when the decay starts. Now disposal. Okay, the disposal is done by various ways. The conditions favoring disposal by dilution. Okay, so these are the conditions. When the sewage is, when can you dispose the sewage? By the dilution means you can dispose the sewage directly into the rivers or directly into any water body or ocean, whatever it may be, whatever water body it may be. What are the conditions favoring the disposal? So first is when the sewage is comparatively fresh and free from settleable solids. Okay. If the sewage that is flowing out of the effluent sewer is comparatively fresh, you can directly uh, dispose it. Why? Because the dissolved content in that sewage will be much higher, so that would not pose any threat for the aquatic life that on the of the water body that you are going to dispose to. And the second is when diluting water has high dissolved oxygen content. That's what I said. The first thing, if it is fresh, it will have high dissolved content. If it is having a very high DO content, dissolved oxygen content, then you can directly dispose it. Okay. Third, when diluting waters are not used for purpose of navigation or water supply. Now, if you are disposing it to a source, to a water source, to a water body where that water is not used, that body, water body or whatever it is not used for navigation, or those water is not used for water supply. In that case, you can directly dispose. Okay, at some reasonable distance on the downstream from the point of sewage disposal. Like if the point of sewage disposal is A, you can dispose it to a point B, say at a distance of 5 kilometers from point A or 5, so that it is not, that point A is not affected by the disposal, because it anyway from the upstream to the downstream, that sewage mixture will be carried out, so it will get diluted. Fourth is when the outfall sewer of the city or the treatment plant is situated near some natural waters having large volumes. So this is the last point. Now let us get into some standards of dilution based on Royal Commission report. Okay. Now see, on the left side, this column you are giving dilution factor and what is the standard of purification required. If the dilution factor is above 500, that means the disposing water body, the sewage on the water body on which the sewage is to be, that contains huge amount of water, like it's an ocean. So obviously, the dilution factor will be much higher, more than 500. Then no treatment is required. Raw sewage can be directly discharged into the volume of dilution water. You can directly, without any treatment, you can directly dump the sewage into the uh, that that source, water source. Okay. If it is between 300 to 500, okay, less than 500 or more than 300, then primary treatment such as plain sedimentation is given to the sewage. Only primary treatment will be sufficient. You need not go for secondary or higher sewage treatment. If it is between 150 to 300, then treatments such as sedimentation, screening, essential chemical precipitation are required. Okay, again, the pre-filtration, the primary treatment will be sufficient, but it might include screening also. It might include sedimentation with coagulation also. Okay, if it is less than 150, then complete treatment has to be complete, primary to secondary and tertiary also sometimes. Okay, filtration, chlorination, and all this sewage treatment, entire sewage treatment you have to perform, and then only you can dispose. And it should not exceed 20 ppm. This is the clause. So this is another BIS standards for your various parameters of the sewage. They are inland water surface, or where you are going to dispose the water body, and the public sewage. So for BOD 5C, this is the effluent discharge into water surface as per IS. For this is 20 milligram per liter. Okay. Now from public sewage, the sewage that is coming out from the public sewage, the BOD is 500 milligram per liter. The inland water, this is before the treatment. After the treatment, that BOD should be 30 milligram per liter. You have to reduce this 5 BOD that is running in the sewer. That sewage that is running in the sewer, that should have a BOD of not more than 500. And when you are disposing to the water body, it should not its BOD content should not exceed more than 30 milligram per liter. Same wise, COD should not be more than 250 while disposing in diluting water. pH value should lie between 5.5 to 9. Same both in public sewers and both in inland water. Total suspension solid. So these are the limits that are being given. Temperature 40 to 45 degrees. Oil and gases limit should be 100 milligram per liter in public sewer. After treatment, it is 10 milligram per liter. Okay, oil and grease 5 milligram per liter, and before dilution to before disposal to diluting water 1 milligram per liter. So likewise, sulfides, fluorides, residual chlorine, every other component, whatever chemical component that is being required, permissible limits that should match. And if those permissible limits are confirming as per these IS codes, only then you can dispose the uh, sewage into the river. So this is in case of your urban sewage disposal. So we shall also discuss also another topic called the rural. For the rural sewage, what is the way of disposal? So one way of disposal that we have discussed is we are disposing the sewage directly into the water bodies or the rivers or some anything. We could also dispose into lands, that is called as sewage farming, or thickening of. When you dispose sewage in land, the fertility of the land will increase. There you can grow crops also, but that has also got certain limits. So we'll discuss about that in the next class. So that's all for today. Thank you.